Okay, so good morning, everyone, again. And my presentation is completely off topic from the others because at Anchorage, we are already solving real world problems. And so all the discussion we have seen, so it's very important to have, especially on academia. But I feel like my role is to bring us down to the earth and to talk about the daily problems that we are solving, because I believe that some of the problems we are solving will eventually also be useful outside the financial space and can be used on other forms where blockchain will become a reality. And so, well, you already know by now that Anchorage is a digital asset custodian. And we mainly serve institutional clients. So we don't do B2C business. We only work with institutions. And the company was created with the vision that we believe in a safe and accessible economy, strengthened by institutional investment. And we are working to advance this institutional participation in the digital asset class. So the vision for us is, although we are going to decentralize technology, companies will not go anywhere. And we are in a space where we believe we can empower most of the traditional companies to evolve into the new way of thinking and working on a decentralized economy. So we are putting ourselves as a player to allow traditional banks, traditional payment solutions like Visa or Square to evolve into a decentralized financial ecosystem. And the problem starts with volume. So when we are discussing different blockchains and how we can decentralize voting mechanisms and basically bring the power back to individuals and take that out of corporations or institutions, the problem is, as the value evolves, then we start to get reports of hacking mechanisms, either it be technological or sociological hacks, and everything that at a given point when it has enough value, it's exposed to risk and attack. And that started first with crypto because it is a money, or kind of a money system. And then what happened was in 2016 to 2017, as the crypto value in the market rose dramatically, institutional, or especially institutions, became part of a huge attack that has been led to private keys. And so these private keys could unlock hundreds of millions of dollars. And I think we can also extrapolate this. If anyone can vote in future using a blockchain mechanism, how can we make sure that people's phones are not compromised in a way that they are actually voting and not someone else is voting for them? And until now, the solution has been cold storage. Cold storage are essentially wallets that are disconnected from the internet. It's the only way to be secure is if we plug the key, or if we plug the cable out of the system. But then it relies on human operations. And where do I remind where I put the wallet, and do I know how to access it? The problem with cold storage is that, well, it's human operations exposing assets, in this case, crypto assets. Most of the banks or institutions, they use checklists. All of them use Excel to manage everything. And then this is all managed by people and Excel spreadsheets. And then you have the manual access is slow and inconvenient. So if we need to get a wallet out of storage, you may actually need to go into a bank, to a vault, to get the wallet. And so all the purpose of having a distributed system, and then we come up again with the problem, or where do we put the keys? And then keys in cold storage cannot be used for participation. So as many more blockchains allow us to stake our assets and to participate in different ways, not only for transactions, we need more and more access to these keys, and we cannot continuously go into the vaults to fetch. So we needed to come up with a way to better manage this problem, and how to do that in a global internet space where we cannot trust any node in the system. And so we created Anchorage for the demand of custody and to solve this problem. And so our solution was to create a system where our keys, the private keys that allow us to sign blockchain transactions, never leave the outside of our HSMs, at least unencrypted. So this means that every operation that occurs in the blockchain, the payload of the operation is actually signed within an HSM, an hardware security module, which is a specific set of hardware that is designed not to be tampered with. And so if it is tampered, it's basically useless because the system basically shuts down on itself. And so we receive these operations that by themselves, I'm going to explain how, but by themselves, they already need to be signed outside the HSM. And then when we reach a consensus, we basically allow the HSM to sign a payload to execute on a given blockchain. And this solution works on several different sets of blockchains. There is work on integrating more and more different blockchains, especially if we talk about different families of blockchains that use different sets of ways to build their payloads. But in essence, what our platform allows you is to not need to know the specifics of a blockchain and execute transactions in any way. So one of the keys to the success of Anchorage is that we are experts on building custom firmware for HSMs, which allows us to create very complex solutions that are coded within the HSM. So the HSM itself does a lot more than what traditional banks or traditional finance does with HSMs. Because again, I think this is also important. We are using battle-tested technology to do this. So HSMs have been around for 20 years or more, and traditional institutions use them for different kinds of use cases. The big difference is what we were able to do with their firmware and the extent we were able to customize that firmware. We actually have a paper on our blog called Smart Storage, that if you want to know the details, the technical details on how we do that, you can find on our blog. And so we actually use, on some devices, phones have secure enclaves, like the iPhone, so which is a hardware module that allows you to sign payloads. And we use that technology to make sure that we are actually or this is one of the things that we use to make sure that we are actually talking with the person that we are supposed to. And so at least that it has the phone. The phone itself, to unlock the secure enclave, usually is associated with biometrics. And then on top of that, we add our own biometrics gathering, like having someone speaking to the phone each time they want to do an operation. And then we make sure that we got a voice recognition. We take all kind of parameters out of the phone, like how many steps have you taken. It's that the number of steps that we usually do, and that could raise a warning in our systems. And so we have built this digital assets platform where there is no password. So you don't need to use a password on any step of the journey. So you only need to be you. We only need to access your biometrics, and then we take it from there. This allows us, or our customers, then do staking. They use their assets in order to capture yield. And governance, this is important as more and more blockchains, they enable you to decide the future of the network by using your assets to make decisions about the future of the chain. And as we evolve and we are getting calls by many different players in the financial sector, we are actually learning new ways of using this platform to enable day-to-day operations. And as part of PRR, we are also working with Siege, the creators of MBWay. And so there are multiple use cases where we can see in the future MBWay, for instance, being converted into crypto. That was it from my side.
Hey, so my question is, how do you generate backups of the keys? How do you manage that?
The backups of the keys?
So the keys are generated inside the hardware device. So if the hardware device dies, do you lose the key?
The hardware devices are actually stateless. And so we don't store any state on HSMs. The keys themselves, they are stored, and we have multiple backups of them, but they are encrypted with the key that only the HSM has.
If the HSM, so the keys are encrypted with the key generated by the HSM. So where do you store the key, the generated key?
That's a secret sauce that I cannot explain. But it is possible that I can tell.
I mean, you could explain to you, but then you would have to do it. So.
Yeah, with an NDA, I would love to explain you how to do that.